So you've come to learn physics, huh? Specifically, the physics of a basketball chest pass? Well, you came to the right place. Let's jump right in.
So in basketball, there's three types of passes. There's a bounce pass. There's the overhead pass, which is just like this. And then there's the chest pass. Basketball also uses many concepts of physics. The first concept is Newton's first law, and it states that an object in motion has to stay in motion and an object at rest has to stay at rest. So here I have this basketball, right? And it's just sitting in my hand and it's at rest. But if I were to perform a chest pass, then the object is being, there's a force being applied on the basketball from a chest pass, and it would be still staying in motion, but this idiot over here is standing in the way and stopping it. Pass it back! In basketball, when we are doing chest passes, we're using force. We are putting force onto the ball. And this goes hand in hand with Newton's second law, which is force equals mass times acceleration, right? So basically, we can find the amount of force that I'm putting into this chest pass. We can find how much force I am putting into this chest pass by finding out the mass of this basketball and finding out the acceleration. And when we do that, we can find out how much Newton's third law states that every action has an opposite but equal reaction. So if I do a chest pass onto the backboard, I am putting force into the ball. And when it comes off that backboard, it is doing an opposite but equal force. So as I do that to the back of the backboard, the ball comes back. Because my force that's being applied onto the ball is reflected off of that backboard. Because that's Newton's third. So in basketball, specifically chest passes, there is also examples of forces being applied on the ball. So when I am doing a regular chest pass, I am applying a force towards DJ, and there's also an upwards force from me because I have to push it against gravity because gravity is pushing down on it. And there's also a force of resistance because he is catching the ball. So here's a quick demonstration. As you can see, the ball went a little bit down in its path. He fought gravity.
Basketball chest passes also use work and power because we have to work to move that ball from a resting position into motion, and that requires power and force. Now that we know the concepts of a basketball chest pass in physics, we can now answer some practical questions from what we have learned.
So here's some practical questions. How much force does it take to accelerate a 0.623 gram basketball to 5 meters per second squared? So in order to find this, we would do Newton's second law, which is widely used in a chest pass. And the equation is force equals mass times acceleration. So we would just do force equals 0.623 kilograms times 5.0 meters per second squared. And the force comes out to be 3.115 newtons. So for a basketball player to do a chest pass and accelerate it to 5 meters per second squared, it would take them 3.115 newtons of force. So here's the second problem. How much work does it take to chest pass a basketball using 5 newtons of force to a teammate that is 5 feet away? So we're just going to use the standard work equation, which is work equals force times delta distance. And we convert for this equation we need to use meters, so I converted 5 feet into 1.524 meters, and we just plug that into the equation. So work equals 5 newtons times 1.524 meters, and it comes out to 7.62 joules. And basically what that means is a basketball player would need to use 7.62 joules of energy to send a basketball 5 feet away using 5 newtons of force.
Oh, good job! Oh, hey! Thank you for watching. I really appreciate it. Now you know how physics works in basketball as good as I am as Fortnite. Oh! Somebody cut that! Oh my god, I can't believe I included that.